sigma equal to V by H1. That is cot sigma 1 equal to H1 by V. Similarly, in second plate, cot sigma 2 equal to H2 by V. But follow. So cot square sigma 1 plus cot square sigma 2 equal to H1 square plus H2 square by V square. What is value? H1 and H2 makes an angle 90 degree. So from here, H equal to root over H1 square plus H2 square. Parallelogram law of vector, that is H1 and H2 root over H1 square. Putting the value of this, we will get this is cot square sigma. Okay, very important question. In maybe there may be numerical value of sigma 1 and sigma 2, and we will get the result of sigma. This type of question may big question for 3 marks, MCQ question. The figure is clear. I think that the figure will clear to you. Now the next question. Now follow. This is Earth. Magnetic north. This type of figure many times I have drawn. This is magnetic north, this is magnetic south. So this plane is magnetic equatorial plane, equatorial line of plane. This place, suppose this is alpha. Alpha be the magnetic latitude. Magnetic latitude. Alpha be the magnetic latitude, and sigma be the in this place sigma be the angle of inclination of angle of dip. Or so prove that tan sigma equal to 2 tan alpha. This is MCQ question maybe, but for broad question maybe 3 mark. Prove that tan sigma equal to 2 tan alpha. Alpha be the magnetic latitude. At any place, at a place on the Earth's surface at magnetic latitude alpha, the angle of dip or angle of inclination is sigma. So that the relation between them tan sigma equal to 2 tan alpha. Follow. This is the magnet, the hidden magnet. This is the south pole. This is the north pole. We know the south pole of the hidden magnet towards the north and north pole towards the south. Now this is the alpha here at a place, this place. In this place, the magnetic moment, we know in my previous class I discussed the magnetic moment is from S to N. Sorry, N to S. Magnetic moment is N to S. from S to N. So magnetic direction of magnetic moment, sorry, this is S, this is N. So magnetic moment in this direction. S to N. If we resolve this magnetic moment in two components follow. One is in this direction and another is in this direction. In my previous class, this type of problem I proved that at any point due to find out the magnetic field at any point due to a bar magnet. Clear? The magnetic moment M. So in this direction, this is the alpha. So this angle 90 degree minus alpha. So in this direction, the magnetic moment M sine, that is M cos alpha, and in this direction M sine alpha. Clear? If we resort the magnetic moment into two components towards the axis in this direction M sine alpha, and perpendicular to this direction M cos alpha. Now here the magnetic moment now follow here due to this portion, this is portion, the follow in this direction, so magnetic field will be in this direction, and due this portion the magnetic field will be in this direction. Clear? Sorry, Sn, the magnetic direction M sine alpha. Due to axis, on the axis the magnetic field will be towards the magnetic moment, and on the perpendicular bisector, that is tangent B position, on the at any point on the perpendicular bisector the magnetic field will be in the opposite direction of the magnetic moment. So here and here in this direction mu naught by 4 pi 2m sine alpha, 2m sine alpha by this distance, suppose d cube, and in this way mu naught by 4 pi m cos alpha by d cube. This is 90 degree minus alpha. So this is 90 degree minus alpha. This is in this direction cos 90 minus sine alpha, and in this direction sine 9 cos alpha. Clear? So resultant field in this direction. So this angle sigma, because total earth magnetic field makes an angle with the horizontal line, is called the angle of dip, angle of inclination. So tan sigma equal to, this is vertical component, and this is tan sigma equal to, this is this by this by this, that is 2 tan alpha. Clear? This is the short question. Nowadays the pattern of question is such that this is a MCQ question. Maybe value of alpha is given and you have to find out the sigma, or value of sigma is given, you have to find alpha, or MCQ relation. But for dot question, maybe this type of proof. Okay, very important question. Tan sigma equal to 2 tan alpha. Clear? At any place at alpha magnetic latitude, if the angle of inclination is sigma, prove that what is the relation between them. Tan sigma equal to 2 tan alpha. Clear? Now, another type of problem. Suppose problem number, next problem. Suppose at any point on the Earth's surface, angle of dip, that is angle of declination, 45 degree. Okay? Angle of dip is 45 degree. Clear? If the dip circle, follow the language, dip circle rotates through 60 degree, what will be the apparent dip at that plane? What is the problem? Angle of dip at a place is 45 degree. If the dip circle rotates through 60 degree, what will be the apparent angle of dip at that plane? Which plane rotates through the 60 degree. Clear? Now, this is the magnetic meridian. This is north. Magnetic north. Here the angle of dip 45 degree. Suppose the plane rotates. This is the plane. Rotates 60 degree. This is the 60 degree. Rotating in this way. What will be the follow? Here the vertical component H, but here H1. H1 equal to H of cos of 60 degree. But vertical component are same in the both plane. So tan 45 degree equal to V by H. Okay, tan 45 degree equal to V by H. From here, and in this, what is the angle of dip? If the apparent angle sigma 1, then V by H1. So V by H1, H cos of 60 degree. H1 equal to H cos of 60 degree. Follow, this is the H. So this is H cos 60 degree. Putting the value of from this equation V equal to H. So this is H by H cos 60 degree. Putting the value of 60 degree, you will get the value of sigma 1. Clear? Follow. Angle of dip circle rotates through 60 degree. So in the apparent angle of dip sigma 1, tan sigma 1 equal to V by H1, vertical component same, both the plane. So V by H1 equal to H cos 60 degree. This is H cos 60 degree. Putting the value of from this relation V equal to H, we get the value of apparent dip angle. Different type of problem today I already discussed. Another type of problem. Suppose this is the geographic north, and here magnetic north. So suppose this angle 12 degree, this angle 12 degree west. This is geographic east, this is geographic west, this is geographic south. Follow? 12 degree west, here angle of angle of declination. Angle of declination. The angle of declination at a place of 12 degree west. That means the angle between magnetic meridian and geographic meridian at this place is 12 degree. And if a magnet which can easily rotate in a vertical plane at that place, then that the north pole of that magnet will tips towards the west. Clear? I repeat again. What do you mean by angle of declination 12 degree west W at a place? There, the angle between geographic meridian and magnetic meridian is 12 degree, and if a magnet is allowed to rotate at that place in a horizontal plane, then its north pole will tip towards the west. Clear? In this place, a shipman, suppose he can drive his ship in which direction? A sailor will go towards the east. Will go towards east. So in which direction will start according to his compass, magnetic compass? So this is in which direction? Follow? In magnetic compass, this is the north direction, north pole. In this way, the north pole. So he have to start towards east in this way. So this angle 90 degree. So from this, according to his magnetic compass, he have to start in the direction 90 degree plus 12 degree. That is 102 degree east. 102 degree east from the north position of its magnetic compass. So magnetic north in this direction. So he have to start from here 102 degree east. Clear? If maybe if it is 12 degree south, what 12 degree east? Suppose the angle of declination 12 degree east. So in which direction he have to start? In this way. So he have to start to go to east. 90 degree minus 12 degree. That is 78 degree. 78 degree east from its position, because his compass will indicate the north direction in this way. So from this direction he will move towards the east with making an angle 78 degree. 78 degree. This is another type of problem. Clear? Now we shall discuss the neutral point of a magnetic field. Suppose this is a bar magnet. We place it north pole towards the earth north and south pole towards the south. Then follow this figure. This is the hidden magnet. This is the geographical north. So this is south pole and this is north pole. Times here again I indicate it. Now we know the magnetic lines of force starts from north pole and ends towards this is the magnetic lines of force. Clear? This is a closed loop. North starts and this is the S. So here follow the magnetic lines of force for north to south. Very important point. Now actually the magnetic lines of force for earth, but this is the north pole. So from for the Earth, the lines of force starts from, this is south, from south and ends to north, towards the north, just opposite to the bar magnet. So if we place a bar magnet at a place, its north pole tips towards the geographic north, but towards the Earth north, then this is the lines of force for bar magnet. Clear? Follow? But for Earth, follow, south to north, these lines of force due to Earth. Follow, in this place, the two lines of force are opposite to each other. So here we get the neutral point, no field at all. This cross point and again neutral point. But here follow, this is for bar magnet and this is for Earth magnet. So if we place a bar magnet of its north pole toward the north of the Earth, then the neutral point will be placed on the perpendicular bisector at the same distance on the two sides, perpendicular bisector of the bar magnet. Clear? This is the neutral point. Follow, if this is the length of the magnet 12 and pole strength m, then we know that the field here, if this distance is d, then field F equal to, we know, mu naught by 4 pi m by d cube. Clear? So if the horizontal component of Earth magnet H, then here H equal to F. H be the horizontal component of Earth magnetism and F be the magnetic field due to bar magnet. These two magnetic fields are equal and opposite in this place. That is why we get the neutral point. So what is the neutral point? The neutral point at a magnetic field is such that where the magnetic field of bar magnet and the magnetic field of the Earth horizontal component of Earth magnetic field are equal and opposite, then that point is called the neutral point. So this is very important point. Then if we place a magnet, its north pole towards the north of the Earth, then what is the position of the neutral point? On the perpendicular bisector, on the perpendicular bisector. Clear? Now, from H, if you get the value of, suppose the value of H is given, so mu naught by 4 pi m by d square plus L square 3 by 2. Remember, in my previous class and also electrostatics chapter, I discussed